Okay, so here's an example. Here's the object. That's where the image forms. It's not a real image, it's virtual. It's upright, it has to be because it's virtual. So if you were looking at this, that's where you would actually see it. The one that comes in parallel, it's going to reflect away. Where does it appear to be coming from? Trace it through the focal point. Okay, the one that goes through the center reflects this way. You can see all these are spreading out, right? This one is going that way, this one's going that way. All the reflected rays are spreading out, so you've got to trace them back to where it appears to be coming from. So the image is actually formed there. Okay? Good. Excellent. So the three rays, just that one additional step. So you can get an upright upright virtual image for this kind of mirror, for the convex mirrors. Now the image over here is like, inside the actual mirror. So if you've ever looked at one of these curved mirrors, you see yourself in there. This is going to be upright. Okay, so here S prime is negative. I guess the way to remember that is virtual S prime is negative. Okay, good. Same thing, you do the three rays. The nice thing is you get your own formula sheet, so you could put whatever information you want on there. I would definitely have a picture of some of these. We'll put together like a nice table of these sign conventions too. So the rear view mirror on the driver's side of a car is a flat mirror. Maybe you've never noticed this before. The mirror right next to you on the door is a flat mirror. The mirror over there on the passenger side is actually a convex mirror. Right? It's further away from you, and you want to be able to see what's down the road. So why is it convex? That's kind of a trade-off. Let's see if I got a picture of it. Must have got rid of that picture. All right, I'll have to get a better picture of that. It's important for the driver to have a wide field of view from either mirror. And when you're over here, you're farther away from that mirror. That mirror actually says, anybody know what that mirror says? Objects may appear closer. So let me see what I do with this picture. Because I had a nice picture of this one. No. I must have accidentally erased it. All right, I'll have to find that picture, because I had a really good picture of this. That's weird. See, there's a whole bunch of words there, but the picture was way better. I'll have to locate that picture that I had. I think I must have accidentally erased it. So anyway, the reason it's there is so you have a bigger field of view, right? Because it's the shape of the mirror can take in more light, and you can see it better. Sometimes if you go to a store, they have that kind of mirror in the corner, and you can see basically the whole store, right? You look in the mirror, it's taking in light from everywhere, and you can see a virtual image in that kind of mirror. It's the same thing for the passenger side door mirror. So take a look. One will say appears closer. The other one doesn't say anything on it. And the reason is so you can take in more and see a bigger field of vision with that. Okay? Cost the car companies more money, right? Because they've got to have two different kind of mirrors, but that's okay. It's for safety reasons. Oh, and like security mirrors. All right, I'll try to find that picture and put it on there for the next time we go over this stuff. Okay, so let me just show you the thin lens equation. So I'm going to have to extend the homework maybe until like Sunday night. I'll make a video, finishing up this part. We only got like a couple of minutes left, but let me just at least show you where this equation comes from. So here's focal point. Same thing we had before. Object distance, image distance. S prime is where the image is formed. Here's the focal point. So this little distance here is S prime minus F. The reason I'm showing you this is we're going to use similar triangles and come up with this thin lens equation, which actually also works for mirrors. Okay, so looking at a couple of similar triangles, h prime over h. So this distance to this distance is the same thing as s prime minus f over f, as this distance is to this focal length distance. So if you just look at similar triangles, you can come up with this. We also know, though, that h prime over h is equal to the magnitude of s prime over s. That's what the magnification is. As you can see up there. So if you take that equation from the previous slide, from similar triangles, this is what we got earlier today. Put it together, substitute this in for h prime over h, s prime over s is equal to s prime minus f over f. Do some algebra. It's a little bit tricky, but not too bad. You literally just go through and divide the whole thing by s prime, it looks like. And you get 1 over s is equal to 1 over f minus 1 over s prime. So all the details aren't there, but that's the idea. This equation, just by doing a little bit of algebra, you come up with this equation. This simplifies to this. So we have 1 over s is equal to 1 over f minus 1 over s prime, or you could write it like this. 1 over s, that's the object distance, plus 1 over s prime, the image distance, is equal to 1 over f. So s is always positive, that's the object distance. S prime can be positive or negative. S prime is positive if it turns out to be a real inverted image. S prime is negative if it's upright and virtual. Turns out f is positive for converging lenses and concave mirrors. So converging lenses, concave mirrors, f is positive. For diverging lenses and convex mirrors. Did I say that right the first time? Okay, let me start over because in my mind I think I said it backwards. So for converging lenses and concave mirrors, f is positive. For convex mirrors and diverging lenses, f is negative. So I'll make a nice little table of all these things. If you look at the summary at the back of Chapter 18, they have a nice table, but it's missing just a couple of things. So you could use this for mirrors or lenses. So the sign of the focal length can be positive or negative depending on the type. Here we go. Nice pictures and a few different things about this, about s and s prime. Okay, but I'm going to come up with a better table of all these different things. Okay, so again, I'll extend the homework. I'll make a short little video just kind of wrapping up Chapter 18, and then since we're not going to meet in person on Wednesday, I'll do another video with Chapter 19. Okay, any questions? I know you got a whole bunch of information. Stick with it. I think you'll be okay. It's just getting all the s's and s primes and minding your p's and q's together. Okay? If there's no questions, that's it for today then. All right, thank you very much.